Yeah, good evening from my side. It's a pleasure for me to be here to speak to you about our vision, what the fourth industrial revolution can do for the metals and mining industry. My target today is to give you a flavor of SAP from a different angle. You may know SAP as a transactional financial system that you may be also using for creating purchase orders, or maybe also used for plant maintenance. But you typically don't link it up with a system that you find in operations or a system that is directly linked with operations. And I was selecting a few examples to start changing that picture in the mind of some people. So what is the challenges that we are faced with? Obviously, many of the mining companies, like you see in the middle part here, will have a digital core embedded. As an organization, obviously, we're looking at what does digitization mean for the various industries, and obviously for mining and metals, it has a big impact on streamlining operations. I guess the speaker after me, the company that he represents, they have detected, McKinsey study has said that while many organizations have over the years improved efficiency, mining is one of the few industries where the efficiency has actually declined over the last years. And to counter that trend, companies have to embrace digitization, establish a digital core, also be faced with possibly new players in the industry that they have not expected so far. And I think everybody is clear that there is no debate about whether you have to integrate or have to innovate. It's just a question how quick you can do that. So currently, and that's another study, 90% of all CEOs believe that digital economy will impact their respective industries. But tragic part of that is many of, as few as only 15% have a strategy already in place. So there's a lot of work to do. If you look at the digital technology trends, we are talking about Industry 4.0, but we're also talking about other digital trends that are, let's say, connected to Industry 4.0. It has been mentioned before, machine learning, artificial intelligence is certainly also an important technology that you use robots to make processes more stable. Obviously, cloud computing plays a role here when it gets into quick deployment of new technology and connectivity as well. And finally, of course, Internet of Things, the connectivity of machines, of equipment, of sensors into your business world is playing a big role here. How do you connect Industry 4.0 and Internet of Things? And this picture depicts our vision of it. Industry 4.0 is something that evolved in the manufacturing industry, where you see the typical traditional 4 layers of ISA 95, with the top layer being ERP, the layer below being manufacturing execution systems, SCADA, and then eventually the machine layer. In Industry 4.0, the integration between these 4 layers becomes more or less obsolete, or the need for, let's say, not bouncing information one step higher and higher is not the right approach anymore. You have to be able to seamlessly go through the layers to make real visibility of what's happening in the operations. So the whole IT-OT conversions is meaning just that. That doesn't necessarily mean that all devices communicate with everything, but we cannot let's say, continue establishing layers in communication between operations and the enterprise. And if you extend that theme into Internet of Things, obviously that expands into all industries and into all types of devices and all things, whether it's machines, of course, but again, factories, that can be trucks, that can be cars, that can be planes, that can be buildings that measure power consumption. All of those things can send signals through the internet that can be evaluated to make, to improve basically the efficiency, and with that, obviously, your cost of operations. What is the potential value that you get from IoT? Obviously, you can establish new business models, and companies have started embracing that already. 15 to 25% can experience faster revenue growth. New business models, for example, equipment that a company has been selling is giving them information back about the usage of the equipment. So you can establish models like power by the hour. You can establish models, how many tons have a truck moved from A to B, how many holes has a drill been drilling, how many compressed air did come out of a compressor. If you know these quantities, you can charge your customers not by selling equipment, but by whatever the equipment has performed for them. And these models have, as I said, already started materializing. Asset optimization is another big topic. Obviously, you can utilize your asset better if the maintenance can be better predicted. That can drive down maintenance cost, but also make the machine availability more reliable. Again, mentioned already in the two previous talks. You can also achieve higher operational excellence, higher productivity. You know better from sensors again, what is my exact production volume, what is my produced grade, and so on. And you can establish, let's say, feedback loops and change the processes while you're still in the production process of a previous step. And finally, you can also utilize it for inventory optimization. If you just think of tracking shipments and make it more reliable when that you know exactly when the shipment will be arriving. You can also measure using RFID devices, for example, where exactly is my piece of equipment. If you think of a large factory or let's say a mine with many shafts, it's important to know exactly where to find your inventory. So those are a lot of potential values. Now let me switch to some customer examples that have in common that they all utilize in one way or the other new technologies of Internet of Things or new technologies of machine learning. And I've picked examples from very different areas, but tried to stay in the mining industry for applicable examples to you. Now the first one is from an Australian iron ore mining company who have utilized a product we call Vehicle Insights to, for them, drive immediate savings. What they do is a very simple thing. They track some of their vehicles, light vehicles, higher vehicles and buses that both operate inside the premises of the mine but also on public roads. And the first benefit they get out of that is a tax refund of fuel tax. Because if an equipment is operated on private roads, the fuel tax is not applicable. And by having a device that tells them exactly the distribution of percentage-wise how many kilometers have been driven on private road versus public road, they can claim that with a very precise tool. And besides that, obviously, I mean that fuel tax credit made it possible for them to capture, to recover the cost of investment within 3 months, as small as 3 months. And it has additional benefits for them. They can obviously now shift the maintenance of those vehicles more into usage-based models, and finally also better utilize the fleet that they own versus renting vehicles. A simple case that again provided immediate savings. Completely different area was a case done here in Vale, a mining company, very well-known iron ore miner in Brazil, #1 in iron ore. They faced a challenge in their procurement area for maintenance parts. The challenge that they tried to address was that many of their procurement or purchase requisitions that came from maintenance were rejected because of wrong part numbers or, let's say, quality of data. And obviously, 50% of those rejections they found out were actually because there was a long-term contract with that vendor. Now, how did they try to overcome let's say, the quality of the purchase orders in general? The challenge here is obviously out of thousands and thousands of different parts to identify the right one and then link it to the right contract. And they used the technology very simple, not very simple, actually a very advanced technology. They used image recognition. A picture taken from a part is compared with parts catalogs, and the system proposes a part number, and that way they basically, with that technology, identified the correct part and reduced the number of rejections of purchase requisitions, obviously made the whole purchase order more reliable. And needless to say that this not only adds to availability, better availability of parts, but also to, let's say, fewer mistakes, and obviously you can run the same process with smaller, within a shorter time. Another case that I'm showing is coming from the mining industry again, and it shows the example where a partner of us, a small partner who is actually just acting in the mining industry, a company called MineRP from South Africa, they have basically offering mine technical systems that includes mine planning and other things. Now the challenges that this joint solution is addressing is mainly to reduce the planning cycle. Every miner will admit that it takes them 4 months or 5 months to develop a mine plan. Now, how can you reduce that? How can you even develop several versions of a plan, simulate the different scenarios? Obviously, the system example has a few more aspects to address, like have better visibility on resources and reserves, insights into the biggest assets that a mine has, and especially also keep track of depletion of resources and not just do the calculation once a year when you have to finish your balance sheet, for example. And of course, link maintenance plans with the production plan, and other challenges were linked into that. Now, how did they address that? With a joint product that is called Unified Mine Planning and Control. And it very nicely illustrates on the left-hand side of the picture that the mine technical systems domain for MineRP that takes care of the geologic aspects of mine plans, the engineering aspects, includes survey results, includes information from short interval control systems. All that technical side is planned separately, and then it's directly linked into a planning tool that from SAP, which handles the financial side of it and also does, let's say, simulate what this means in terms of revenue and in terms of costs if you fulfill that plan. They did that in several steps. One step obviously was to reduce the planning time, and that they did by using SAP HANA as a platform to come down from months and weeks into days. With that, they were able to do several simulations, different scenarios. What if I develop this shaft further and discontinue this area? These what-if scenarios they did. And then, obviously, the most important thing that came out of that is they are now capable of doing a replanning if the market conditions are changing. If the gold price goes up due to some unexpected things, then it might make sense to replan a mine plan and start mining in areas where they could, at a higher gold price, still be profitable. Another example, more in the steel industry again, and that's probably also similar to what you've seen at Prime Metals example. A German car manufacturer has used, again, a image recognition technology to analyze cracks in the stamping and in the forming of metals. And if you determine these cracks early on, then you obviously save a lot of time and money by not let's say, putting this individual piece through further processing. And obviously you can also adjust machine parameters if needed. A similar example, again, like this car manufacturer we have at a Russian steelmaker, and I liked actually the fact that you can reallocate customer orders. That was also done in Mr. Herzog's presentation. What they actually do is they analyze the quality parameters at the level of a slab already. And they can now predict that with this parameters, steel grade and whatever you have there, they can never meet the standard of the most demanding customer, the most demanding specifications, but that slab may still be usable for another contract that has not as challenging grade requirements. So you can actually target to allocate at the semi-finished product level to see this will eventually feed to this final customer. And that example was from a Russian steelmaker, which is a fully integrated company, Severstal. Many of you would know them. Another example from that very same customer is around predictive maintenance. And I guess we've heard many examples where predictive maintenance is applied. Obviously, it's a traditional IoT case, so to say, that the machine gives feedback, and if you analyze those parameters correctly, you can prevent failures to happen. You can also predict in a much more granularity when the next maintenance schedule is due. Finally, I have an example around improving people safety using variables. This is a co-innovation we've done with another partner from North America called Illumity. What they basically do is integrate a device that miners wear before they go underground. And on the device is actually used for bidirectional communication. It's not only a measure to track where exactly the person is and what, let's say, basic health parameters of this person are, like blood pressure, temperature, and so on. But it's also a device that can be used to send checks and alerts to the miner underground, but also to send them a checklist, like what you need to do in order to check machine conditions. And obviously somebody can send backup information through that. So you have a full sequence of different, let's say, messages back and forth that this co-innovation has been done. Similar scenario we have implemented with a customer in Latin America in Chile, copper miner Codelco. I want to conclude with the key message here is that the orchestra that we need in this case, nobody can do it alone. SAP will not engage in developing picture recognition software or sensors or integration software for sensors. What we are doing, however, is very closely working with the likes of Siemens, of Bosch, of GE Digital, and anybody who can basically help to fulfill that joint vision of a digital platform. So for us, collaboration between partners and even partners who at some areas compete with each other is key to achieve the vision of Industry 4.0. Thank you.